Stored access policies in Azure Storage help administrators manage constraints that apply to shared access signatures, SAS. By establishing policies on containers or blobs, it becomes easier to modify or revoke access rights without having to reissue new SAS tokens. This approach is especially useful for controlling a wide range of operations, including read, write, and delete actions. Storing these policies at the container level helps keep security consistent, preventing misconfigurations or unauthorized viewers. When integrated with previously learned topics, such as firewall rules and virtual networks, stored access policies tighten your storage environment, ensuring only trusted consumers can interact with the data. Access policies serve as reusable permission sets that can be linked to SAS tokens. They include start and expiry times, as well as allowed permissions, ensuring a systematic approach to controlling resource usage. Defining an access policy on a container or queue gives administrators flexibility in modifying or revoking privileges without manipulating each token individually. This structure supports efficient key rotation strategies and helps enforce corporate security guidelines. Furthermore, an access policy centralizes monitoring efforts, simplifying compliance audits. By limiting the privileges within an access policy, you reduce potential risks of accidental data exposure or malicious usage. Shared access signatures, SAS, can be generated with direct permissions, but attaching them to an access policy enhances manageability. Instead of embedding permission details in individual SAS tokens, administrators define a stored access policy that includes permissions, validity, and restrictions. Then, each SAS token references the policy's unique identifier, ID. Updates or revocations happen only at the policy level, saving time and effort when scaling enterprise solutions. This strategy also provides an audit trail for changes. By referencing a single policy, you ensure consistency across tokens and maintain compliance with organizational standards for data governance and security controls. Stored access policies comprise several key parameters. The signed identifier, ID, is used to reference the policy from SAS tokens, ensuring a direct link. Permissions range across read, R, write, W, delete, D, list, L, update, U, add, and create, C, depending on the service. Start and expiry times define the window for valid usage, while the active time range ensures fine-grained control. These parameters must be defined intelligently to uphold the principle of least privilege. By considering resource usage patterns, administrators can select permissions that align with operational needs, thus minimizing potential vulnerabilities and enhancing governance across the organization. In the Azure portal, create or select an existing container, navigate to its access policy settings, and specify the parameters. Provide a signed identifier and configure permissions, start time, and expiry. Once saved, the policy becomes available for future SAS references. Generating a SAS with this policy involves choosing the stored access policy from a dropdown when you create the token. The portal automatically embeds the policy ID, ensuring all tokens adhere to permissions and timeframes you defined. By utilizing the portal's graphical interface, administrators can easily test policy configurations and quickly align them with evolving organizational security demands. Azure CLI offers a scriptable method for creating and managing stored access policies. Use commands such as AZ storage container policy create / account name storage account name / container name / name policy name / permissions rwdl / start mmz / expiry mmz. These parameters define basic permissions, start time, and expiry. Follow up with AZ storage container generate SAS to create a SAS referencing this policy. This approach integrates seamlessly with automation pipelines, allowing you to version control policy changes. By employing CLI scripts, you ensure consistent deployment across multiple environments without relying on manual steps. PowerShell offers a robust alternative for those familiar with Windows-based automation. The new AZ storage container stored access policy can define a policy, while new AZ storage container assist token references the policy's ID. For example, new AZ storage container stored access policy. Name, policy name. Container, container name. Permission, RWDL. Start time, date time. Expiry time, date time. Context, $CTX. You can then pass the policy name into the new AZ storage container assist token to generate a SAS linking to this policy. This integration with PowerShell supports custom scripts and modules, enabling batch updates or scheduled tasks for policy renewal. Consistent usage fosters streamlined auditing and compliance reporting. Organizations often employ stored access policies in scenarios where multiple SAS tokens require centralized control. For instance, scenario policy benefit. Periodic data sharing easily update or revoke tokens delegated access for partners limit privileges in real-time data pipeline automations consistent permission sets in data sharing workflows. Quickly disabling or adjusting a policy ensures time-sensitive information remains protected. Development teams frequently integrate stored access policies into CI/CD pipelines to reduce configuration overhead. By linking multiple SAS tokens to a single policy, administrators maintain control while providing flexible, secure data exchange. After configuring stored access policies, ongoing monitoring is essential to keep them effective. Regularly audit policy usage through Azure Monitor logs and container analytics to verify the correct level of access. If you detect suspicious activity, you can modify or remove the policy's permissions, instantly affecting all linked SAS tokens. Additionally, implement maintenance steps like policy expiration reviews and routine key rotation to align with best practices. Because policies evolve with project requirements, documenting each change is vital for compliance. Leveraging built-in alerts, you can proactively identify anomalies, preserving the security posture of your Azure storage environment. Stored access policies offer room for sophisticated configurations, including layering multiple policies on the same resource. This approach lets you segment distinct user groups or project phases under separate policy IDs for targeted control. Additionally, you can embed Active Directory integrations by combining role-based access control with stored policies, maximizing identity-driven security. Fine-tuning the start and expiry times to stagger token usage helps mitigate concurrency vulnerabilities. As you explore advanced governance models, track policy dependencies in a configuration management database to reduce complications. By methodically planning policy hierarchies, you can address varied organizational needs with minimal operational friction.